Have you ever wanted to be somewhere in an instant? Maybe you teleport to space and beyond, to never be late again, and to even go to Disney World. I'd love to tell you that your dreams can finally become true, but Prince Charming might have to wait a little bit longer. Science isn't quite there yet. However, scientists have recently gotten one step closer to making your dreams a reality through something called quantum teleportation. Quantum teleportation, also known as quantum telephoresis, is when a very small particle transmits information to another particle in the blink of an eye, no matter how far apart they are. This is like teleportation, just on a much smaller scale. These particles, called photons, are able to send each other information so quickly because of something called quantum entanglement. This is when two particles are mutually dependent on each other. That is, if you describe the state of one, you can also describe the state of the other one, no matter how far apart they are. Confused? Well, quantum entanglement can be thought of as the game when someone holds something behind their back and you guess which hand it is in. You know that the object is only in one hand, so the other hand must be empty. If you find out that one of the hands is empty, you know that the other hand must have the object, and vice versa if you're a little luckier. In the same way, with quantum entanglement, if you measure the state of one of your photons, you immediately know the state of the other. So how does this apply to teleportation? Well, let's imagine a group of 3 friends, Andy, Brooke, and Charlie. Charlie has 2 purple entangled photons that he wants to share with his friends. He gives one to Andy and the other to Brooke. Later, Andy happened to have a special yellow photon that he wants to give to Brooke, but she just left on vacation. Well, in comes quantum teleportation. Andy decides to collide his yellow photon with his purple one, and he takes a measurement as they annihilate each other. Because his photon and Brooke's photon are entangled, what he does changes hers. He then calls Brooke on the phone to tell her what happened. Once Brooke receives the call, she checks on what was her purple photon, and wham! It's yellow now. It's almost like the yellow photon teleported in an instant. But was this really in an instant? Einstein said that nothing can travel faster than the speed of light. But the trick about quantum telephoresis is that information isn't actually going from one place to another. The 2 particles are entangled, so anything you do to one immediately affects the other one without having to communicate with each other. This happens in an instant, but the information that is being sent is limited by something called classical communication. If you look back to the analogy, Andy had to call Brooke and tell her that her photon changed. In the same way, with quantum teleportation, the receiver will not notice that their photon has changed until they receive physical information through classical communication. And that cannot travel faster than the speed of light. While quantum teleportation won't be able to take you to Disney World right now, it is still viable for changing the way that we digitally communicate, making it much more secure. And who knows, maybe one day it could be used on a much larger scale.